All right, hey there, chemistry students. This is Miss Ruark. This is just a special vodcast where I'm going to just go back through the calculations for how to double check and make sure that the solution that you have made is the concentration that you say it is. Excuse me. So, in class, you guys made a 0.750 molar HCl solution and a 0.750 molar NaOH solution. Okay, so let's say that I made a 0.54 molar HCl solution, and I am going to titrate that with what is known as a standard. A standard, again, you've heard this several times, but a standard is something that has a known concentration. It's been tested that way. It's been tested, and they've said, okay, time and time again, that's the concentration of it. So the titrant that I'm going to use to do this would be NaOH. And let's say that this titrant has a concentration of, I don't know, 0.8. Okay, so I'm just pulling out numbers from, these are made up numbers. Hopefully you're listening to this. These are made up numbers. Okay, so you guys know how to fill in the chart. I'm just going to go through and show you how to double check. I am double checking this one right here. That's the one I'm going to. So this is my analyte. That's the one that I'm trying to check. Now, if you put your solution in the titrant identity one, that's fine. It doesn't matter how you did it. Just remember that you start with your standard solution and work towards your solution. You always start with the one that you know the most. Okay, start with your standard solution. So let's say that I started off with an initial volume in my burette of 1.90 milliliters. Remember, two numbers after the decimal. And I started with a initial analyte volume of, let's say I did 15.0 milliliters. Okay, all numbers that I know and one that I'm guessing, right? Okay, so I've got 15.0 milliliters of my analyte, and I've got 1.90 milliliters of my burette, or of my titrant, and I start my titration, and I get to that nice pretty pink color, and I stop, and here, let's say that this is 9.87 milliliters. I'm just making up numbers, right? Okay. So now, using this information, we know how to go through and fill out our box. So let's go ahead and start filling it out. We know that if we have 15 milliliters, it's going to be 0.0150 liters, right? Move that decimal over 3 times. Okay, and here I can go to moles of analyte or volumes of titrant, or moles of analyte or moles of titrant. Well, the thing is this is the one I'm looking for, so I don't want to use this one. I want to use the one that's known. If this is my standard, I want to start with my standard. So I need to start with this one here, my titrant, and work towards the one that I don't know. Okay, so this is the one I'm starting with, and I'm working towards the one that I don't know. Well, we need a balanced chemical equation, and we know that we're reacting hydrochloric acid with sodium hydroxide. Okay. And we know that this is going to make sodium chloride and water. And we know that it's balanced, so it makes a 1-to-1 ratio. Okay, now, you've been doing it this way, and when we did these in class with as a solution stoichiometry, we made it look a little different. So let me show you how it actually looked, and then maybe it'll make a little bit of sense. Okay, this is the one. Well, let's go with our standard. We know that our standard has a known concentration of 0.80 molarity. All right, well, how much of our standard or of our titrant did we use? Well, we've got to take these two and subtract them. We find the difference, right? So 9.87 minus 1.9 gives me 7.97 milliliters. But I don't want milliliters, do I? I want liters. So we've got to take this and plug this in down here in liters. So 0.00797 liters. Oh, look. Now, let's come back. We don't have to put this here in liters. We can put it in milliliters because you've seen it that way before. Yes, you have. Okay, so you could say, oh, well, I used 7.97 milliliters of this stuff right here. Right? And if I used 15 milliliters of this, we're saying it has a concentration of 0.54, but what we're doing is checking to make sure that that's correct. So let's solve for that concentration there. Okay, now look, we've set this up like a solution stoichiometry problem. This should look familiar, like, oh my gosh, I know how to do this. Yeah, you do. This just breaks it down into steps for you. Okay, that's all this does. This just breaks it down into steps for you. Right, so we're looking for the concentration here, and we've got to solve for those. So how do we do that? Well, let's start with what we know. Okay, we've got M is equal to moles per liter. And if this is moles of Na or molarity of NaOH, then it needs to be moles of NaOH over liters of NaOH. It all needs to match up together. You cannot put NaOH and HCl in the same one here. The only way you can do that is with the mole ratio. All right, so we plug this in. 0.80 M is equal to moles of NaOH over our liters, 0.00797 liters. Okay, now we solve for moles, and when we solve for moles, we end up with 0.00797 times 0.80 gives me 0.006376 moles of NaOH. Okay. And I even told somebody the other day, I said, you know what? If you've got NaOH here and you want to put NaOH in this box so that you remember that this is what it goes with, then do that. Okay, HCl, HCl, and that's fine. That is up to you, but you've got to make sure that you can keep these straight. You don't want to confuse them. Okay, HCl, NaOH. All right, so moles of NaOH, we have two significant figures here. We have 3 there, so we need 2 in our answer. So we should have 0.0064 moles of NaOH. Okay, now we need to go from moles of NaOH to moles of HCl. So we use 64 moles of NaOH. We know that it's a 1-to-1 ratio, so we set up 1 mole of HCl and 1 mole of NaOH. And look, it's a 1-to-1, so it's going to be 0.0064 moles of HCl. Oh, how convenient is that, right? We love that. All right, so now we have our moles of analyte. We have the volume of analyte that we used, and we're going to use those to find the molarity because that's the final thing that we're looking for, right? We're trying to figure out if we really did make a 0.54 solution or if we thought we did and we didn't do it right. Okay, so we're going to plug that into the molarity equation. Moles of HCl over liters of HCl will give us molarity of HCl. You see how these all match? They can't be different. All right, so moles of HCl, 0.0064 moles over liters of HCl, which is 0.0150 liters. All right. No, we don't want to do that. Let's go back. There we go. All right, so now we're going to plug that in. 0.0064 divided by 0.0150, and we end up with 0.426666666667. All right, how many significant figures do I want? I have 2 here, I have 3 here, so I need 2 in my answer, so 0.43. So my concentration that I titrated it to be would be 0.43. This is my final answer right here. This is your data. Okay, you want to show your data, and this is your work. You want to show your work, but this is your final answer that I'm looking for. I'm even going to circle here. I'll change the colors, okay? Final answer in red. That's what I need. Okay? That's your final answer. That you want to give me. This is your work. You need to show me your work because I need to be able to figure out where your mistakes were if you made mistakes. Okay, and then the last thing, this is your data table. You have to give me your data table so that I know how you got your numbers for your work. Okay, so that's why all of this is important and it all comes together. Okay, so make sure that you give me all of that. Now, I only had one trial on here because I didn't have enough space to go through 3 trials, but I really don't need to, because all you have to do is you should have at least 2 consistent trials. Take those 2 numbers together and take the, do all your work and then find the average of your concentration. Okay, once you find your average, that's your final answer. That's the answer you're going to give me. And when you turn this in to me, you have to make sure that on your data sheet that you have all your work, and you have all your answers filled in. Okay, and that way you'll get your credit for your lab. When you do your test, I'll have a separate piece of paper for you that'll have it'll won't have as many spaces in the data table, but I'm going to take out some of the useless stuff that's kind of in there that we don't really need to have in there. Okay, so it'll be very similar to this. All right, if you have any questions, please let me know, and I'll see you in class. Happy titrating.